Okay, here are our notes for today. I know you're not used to taking them this way, but the nice thing is about these recorded notes is you can pause whenever you need to, write down what we're doing, and then continue the video. Okay, you should be on page 29 of your toolkit. This subtracting integers is our topic. That's towards the bottom of the page. So get yourself there and set up and ready to go. Okay, we talked about this in class yesterday, so we have some examples here that I'm going to take a quick look at. Example 1, we have -3 minus -2, and they're using the tiles, right? They've got 3 negative tiles there. They take away 2 of the negatives, and that leaves -1. Okay, we're going to talk about our subtraction rule here because it's nice to use the tiles, but we also want a way to do this when we don't have to use the tiles, right? So what really happens when we subtract integers, the way that we're going to do the computation, is that you change and you have kind of more room. The way I'm doing these, annotating these notes, I sort of run out of space quickly. So you're going to change your subtract to add. Then you change the second number to the opposite sign. Now it's an addition problem, and you follow addition rules. So I'm going to do that with the examples they gave, and we'll compare because the answers are already here, right? We know that this one is supposed to come out to be -1. So if we have -3 minus -2, the rule that I just gave you, I'm going to change the color here so you can kind of see what I'm doing. The rule that I just wrote here said you change the subtract to add, boom, and you change the second number to the opposite sign, boom. Right? We call this boom, boom, because we make 2 changes every time. Addition or subtract changes to add, second number changes to the opposite. Now, all we have to do is use addition rules, which we have already been working on learning. -3 plus 2, right? And you could draw this. I'm going to draw, I can't draw it there. Well, if we drew that one, you don't have to write this up here. -3 plus 2 would be 1, 2, -3, plus 2, 2 zero pairs, and we end up with our answer of -1, right? Which compares to what they got when they solved that one. So when we change the opposite operation and the second number to the opposite sign, we get the same answer, which is how we know that actually works. Okay, let's look at the second example here. We have -5 subtract 2. Okay, that problem, I'm going to draw a little line here so we can see between. -5, I'm going to try and write a little smaller, subtract 2. And so I'm going to use green. It's a little more visual this time. Change the subtract to add. Change the second number to the opposite sign. Now this one's positive, so I make it negative. Okay, so now I have -5 plus -2. Solve that. When the signs are the same, we add them together. This goes back to our addition rules, which we wrote down. 5 plus 2 is 7, and the sign doesn't change. Negative, negative, negative. Oh, look at that. And it matches the answer they got there. So that one works. Okay, last example is 3 subtract -3. 3 subtract -3. So again, our rule is this. Change the subtract to add, change the second number to the opposite sign, so that becomes positive. And so now that is 3 plus 3, and 3 plus 3 is 6. And there's the 6, right? So you can look at the tile models. They're showing you how that works with the tiles, but we use this kind of shortcut method when we're just solving without drawing the whole model. Change the subtract to add, then the second number to the opposite sign, and then you basically at that point use your addition rules. And you do that every time, you will get the right answer. Okay, make sure that you have all that written down, and that is it.